So in this video, we're going to talk about electric fields, and the one after, we're going to talk about electric fields and comparing them to gravitational field. So electric field is the area where charges experience a force. This can be compared to gravitational fields. So gravitational fields where mass experiences force. So in this diagram, you have a positive charge, a negative, and a positive and a negative charge. To draw these electric field lines, you take a small positive charge. So if I move a small positive charge, it's going to repel. So that gives the direction of the electric field. And so if I bring another small positive charge here, it's going to be attracted towards it. So that gives the direction of the electric field towards that charge. And also, when you get closer and closer to the charge, there'll be greater the repulsion. So this can be shown as the field lines. So these are the field lines. They are more closer together at this point compared to this point. So the electric field is stronger at this point compared to that other point. So in here you got the positive and negative charge, and the electric field is going from positive to the negative. And again, you're using a small positive charges to draw your field lines. So small positive charge fix for negative charge as well as positive. So every time you're trying to draw electric field, think about how will a small positive charge behave when it's near the thing that you're testing. So in here we have a couple more charges. Notice that the field is stronger at this point because the lines are getting closer together. So at this point, if you have a small positive charge, this charge is going to repel it as well as this. So you expect it to be stronger here. So this can be shown by the field lines coming closer together. The same here as well. If you have a small positive charge, it's going to get attracted by this as well as this. So that's why the lines are closer together. And also, if you have two lines of positive and negative charge, so you can think of this as two plates, you have fields that are going through. Notice that the field lines are equal distance apart. This shows that the electric field is uniform. And also, it's important that they're curved at their edges. Okay, so there's an important point. The electric field lines, you must draw them right angle to the surface, right? And they're also directed away from the positive charge and towards the negative charge. And the field lines never cross over. So electric fields affects charges. So what is a charge? So we can define charge as Coulomb. So what does that number means? You guys know what is electrons are, and an electron will have 1.6 times 10 to the minus 19 Coulomb. So that's a very small number. So that's a charge on a one electron. So if that electron was in an electric field, it will experience a force. So what does that mean? So 1 Coulomb will equal to 6 times 10 to the power of 18 electrons. So that's just 1 divided by 1.6 times 10 to the power of 19. So generally the charge is represented by a small q, sometimes big Q. So Q stands for charge, and it's measured in coulombs. So another way of thinking about coulombs is, you can think of it as mass in a gravitational field. So 1 Coulomb is quite a big number. So if you thought about like just atoms, 1 kilograms will be like millions and millions of atoms. So it's not very practical. So we have made a unit called kilograms. That is the mass of millions and millions of atoms. So in this case, 1 Coulomb is millions and millions of electrons. So it's easier to deal with when you're using larger charges.